Hello everyone, I've got my PCBs, come well wrapped, they come shrink wrapped in a thing, and they come with plenty of packaging. I tell you, they're really well packed, and I got them pretty quick as well. It only took a week, even though I chose the cheapest postage. So here's one of the PCBs I designed for this project. This is for my well, we all know it's for my 4-wire 4-wire low resistance meter. I'll go into it in more detail, but it looks really nice. Let's see if I can get some focus. Without getting my light in the way. I'll just so hopefully this is going to be the build. I just want to show you how I got the PCBs. Alright, so I've gone through the circuit diagram. So let's just have a look at the PCB editor. This is it finished. I've done a video. I really made a mess of a video. It's about just give me a minute. It's about 2 3/4 hours long, and I made bits of a mess. It's a bit, but I went into detail of how I created this, showing you how I ended up making a layout like this, and why I've used certain components. And let's just open up the 3D. Make that smaller. So this is a 3D version, and basically I decided to make it all through hole and make it more like a motherboard that takes the components, that takes the modules, and I explained this extra header row of pins. And what I intended to do. So what I want it to do is I want it to look something like this. I want a low profile. What you can do is you could actually just put headers in here, sockets, and just plug them in, so you can plug them in and out. But what I'm going to do is I'm going to make them make it a low profile, and the reason I've used this there's only one surface mount component, and that's this socket here, and that's because I've got a bag full basically. Where are we? SMD. There we go. Turn that on as well. Yeah, I've got a bag full of them. Sometimes. Yeah, sometimes it's easier buying things in bulk. It's cheaper than buying just maybe 4 or 5 of them. So I've ended up with bags full of sockets and plugs and sockets that I can make up my own plugs. So what I'm going to do is I'm going to make my own plug using this. I need 4 of them. Let's just get them, because I'm going to need 4. Am I in focus there? Let's sort of get it in focus. It's a bit better, isn't it? 1, 2, 3, 4. So I'm going to need 4 of them to make for the cables on my probe, and we're going to need a socket, like I say, getting a bag of sockets, plugs, getting this bag was cheaper than just buying one or two. Basically, it's all to do with postage. Really, it's how much they weigh. If they're not going to weigh a lot, then it's not going to cost much in postage. So that's a lot of this stuff is based on that fact. So if you're ever shopping around on eBay or AliExpress or anything, consider how much it's going to weigh when they tell you to sort of like add a few more. It's just to get it just under the next postage tariff, basically. And so yeah, I'm going to use this to sit on here, basically, and then I can use that plug to plug my leads in. And I'm going to use I'm going to use 4 of these. I'm going to use a blue and a yellow, a red and a black, I think. So let's get one of them out. So we'll have a yellow one. What I'll do is I'll have blue and yellow for the current, and then we'll have a red and black like I did before for the voltage. So yeah, so I've got the four probes we need. Just put them out there. I'll stick them out of the way now. Yeah, so I've got a nice PCB from PCBWay. So let's compare it with what I've got. Oh, let's see if I can get my light out at the frigging way. And I wonder if I put it over there. That's not too bad, is it? What the hell's shining on it now? I don't know what that is, but that's not too bad. So yeah, so this is what I've designed. Let's just move that across a bit. Yeah, that's what I've designed. Let's just take off the components again. So it looks pretty much like that, doesn't it? Yeah, very good. It's exactly as I drew it into it. And let's have a look on the back as well. So on the back, yeah, I've got my pad here. Let's just yeah, that one is actually closed. That's for my pull-ups. If you don't want pull-ups there, you can cut through that. And this is for these 4 pads. But you can see them better here. Got no but my reflection on there. But yeah, it looks fantastic, doesn't it? Yeah. Like I say, for the price, I can't. Well, we can't make one of these ourselves for the price that they are. I think I got 10 of these, and basically it's £1 a piece. I mean, for £1, what more can you do for that? Eh? Anyways, so close that, and then I'll just make that narrower, and you can see. So yeah, what you'll have to do is you'll have to tell me what if you want me to upload my other video. Like I say, my other video is about, what did I say, 2 3/4 hours long, and I made a bit of a mess here and there, and it might show you something that you might want to know about, and what have you. It's how I came to get this together, like so. But what I do want to show you is these two plugins. These are 2 plugins by PCBWay, and it makes it easier for uploading your finished product. Just give me a moment. Alright, yeah, I don't want to close my Explorer yet. I'm watching this what do you call it, Sword, Snow and Strength. There's so many episodes, I don't want to lose track. Anyways, so what I want to do is, anyway, we can't see the plugins. There we go. So basically, once you've done your PCB, you always run a design rule check. There's certain things that you want it to check and make sure you haven't made the right cock up. So yeah, tick that and it'll run the check. Oh yeah, run the button, goes through it. What we're looking for is all green. Alright, I've got a warning here. Right, so this doesn't actually match the copy that's in the library. That's because I've been editing it really. But this is fine. What it's telling us is this one here. This thing is not what's in my library, and that's because I've done some editing to it recently. So I know about that. So what I'm going to do is I'm just going to right click this and exclude that violation, because I know that this is correct. This is what I sent off to PCBWay, and I've got the PCB bit back, and it's all just as I saved it. So once you've done your check, basically, if you've put these plugins, what you can do is if you just go to onto the main startup thing for KiCad. What we've got here is our plugins in Contents Manager. So if you just click on that, it'll tell you what you've got, and I'll just click on installed, and you can see I've got the PCBWay plugin. This is the one you want for ordering your PCBs, and I've also got this plugin here, which is for when you come to actually, if you want to share the Gerber files and drill files and stuff, you use this one, and this is also the one that I use for showing my when I'm writing up my shared project. So we'll look at this first plugin, this one. So I'll close that. So what this should do is, I'll just minimize that. When I click this plugin, see, this is my Explorer. If it was closed, it would open it up, but it's your default Explorer. But you just click this PCBWay button, and it'll come up with a little timer, and then it'll take you straight to PCBWay. You tell it where you are and everything, your postage and everything, and you can see here that it's only a total of $8.75. Now you'll see that the cost is only $5 for 5 here, but it's actually only $5 for 10. So if you go to pieces here and you click on 10 pieces, you'll see that it's still only $5 for 10 pieces. But the only thing that's increased is the postage, and the postage is set by this one here. If you want it in a rush, you can use DHL, or if you're not worried about the actual time it takes for it to arrive, then pick one of these cheap ones. And then you just save to cart, add your details, and what they'll do is they will just have a look at it and make sure that there's nothing amiss and that they can make it, and then they'll just approve it for production and ask you to pay for it. So that's it, simple. Now the other thing, if we go here and if I go to my PCBWay shared projects page, you'll see I've got shared projects, and here's my low ohms resistance meter on my shared projects page. What I can do is, hang on, I'm just going to go sign in. Right, I've signed in, so now I can go to the edit the project. So here, this is where you can actually buy this PCB that I've designed. You just go add to cart and put your details in and everything. But if you are doing your own projects and you're creating your own projects, basically when you go to edit your project, you've got add Gerber files, and you've also got where are we? Upload a bill of materials, and upload a Centroid file, and upload other files as well. This is where I upload. I just zip up the code files for the ESP8266 in this case, and that's what gets uploaded there. But these other three, this one, and this one. This is where I go back to my KiCad, and it's this other plugin. What we do is we just click on this button here, and what that does is, if we go to the main thing of KiCad again, so we go to the main startup, don't know what you would call this, the control panel for KiCad, and if we click this button here, this will open up the project folder, and in that project folder we will find that it's created. After clicking this button here, it will create a zip file, and if we were to look in the zip file, you can see that all the files that you need to be uploaded are in this zip file. So for the Gerber files, oh no, hang on, I got that wrong, sorry. This is the file that got uploaded to the PCBWay to make your PCB. Clicking this icon creates this folder for production, which it creates one to the date that you clicked it. So if I was to click this now, it will give me another folder with a newer date. So I'll just show you that. There we go, it's just created a new one now, and it's actually opened up the folder. But you can see that the folder there is well, this is the date I'm recording this, date and time I'm recording this. So we've got 20th of the 1st 2006. So if we go in there, it will show you that you have these files. This is your Gerber files. This is the Gerber files that you upload to this button here. So when you click this button, you will choose this zip file, which got all the Gerber files in. If we look inside there, it's got all the Gerber files. And if you then do more, when you come down to this position, you've got assembly files, you've got a bill of materials. Well, we can see here that we've got the bill of materials files. It's a CSV file, that's the one you'd upload there. And then we've got the centroid files. This centroid files is the one that tells the machine where to place all the chips, all the components, which is this one here, which is called the positions. It's called positions here, but it's actually the centroid file. In this case, this will not. Well, I don't know. I've made this project through hole. There's only one really that the pick and place machine would do, and that is this thing here. The rest are all through holes, so it would probably be sort of fairly manual to do them. Well, you can do them yourself anyway. If you've made the solderless breadboard. Oh yeah, by the way, what I've done also is we go to Instructables, hopefully it's up now, and we go to my Instructables page. I've actually done an Instructable now that oops, what have I just clicked there? Right, yeah, so I've done an Instructables page where I have given full instructions how to build this. You can first build it on a solderless breadboard. There we go. So you can build it on a solderless breadboard to start with. Then once you've got if you've got all these components, I've made this PCB to take all the components we've used on the breadboard, and that's what hopefully I'm going to make today. Let's continue with PCBWay. So in the projects page, and then you just write up your project and show pictures and stuff, videos and stuff, links. But yeah, I just wanted to show you the main. I don't want to. Yeah, these two main plugins here from PCBWay. They make things really easier for you to upload to PCBWay. So let's get on and build it now, shall we? Let me just set things up. Oh, I nearly forgot. If you want to see me actually making this PCB in KiCad, there is a 2 3/4 hour video that I've done. I haven't uploaded it yet. I don't know if anybody wants to see it, so just let me know. Yeah, so here's my PCB from PCBWay. Beautiful. And I just want to explain this again. So basically what I've got two choices of ESP8266, and they look completely different. But the thing is, these two things here, this is the ESP, this is just the breakout board. So we've got like the two power, this is the linear regulator that regulates it down to 3.3 volts. And this is this square chip, and this long chip is the USB to UART, so we can actually talk to it through the USB. And I think that's what they've changed anyway. I don't know what's on the other side there. This, I've got Pi on this one, but yeah, one's a Lion, which is version 3. So it's Node MCU version 3. Node MCU is the arrangement of the pins, basically, because this is Node MCU also, which is the arrangement of the pins. So let's see if I can get them so you can see both at the same time. So let's try and get some focus on that. There we go. So you can see that they're all named the same. It starts DO at the left and ends in 3.3 volts on the right. But they're all arranged in the same. That's the arrangement of the pins, which is Node MCU. But the actual module is one's a bit wider than the other. The pins in that direction are the same length because, well, they're using the 1/10 of an inch pitch header pins. So the reason I've put this second row on here is, well, we'll go with the one that I'm going to use. So that fits perfectly onto this pad here. Let me just get my glasses on so I can see what I'm doing. So that, have I got it shot? Have we got it focused? Have we? Hell. There we go. There, that's better. So you can see that this fits. Bring it back one. I'll try and do this on screen. No depth perception on the screen. Right, you see that one fits in nicely in that socket there, like that. And this is how I'm going to fix it. I'm just going to solder it in place like that. What you can do is use headers. Hang on, let me get myself a header. Yeah, I've got myself a header. So you can use headers like this, and what you can do is you can put them on there like that, stick it on, and they will fit on there like so. So you've got that sort of situation, and then you can unplug this and plug it in when you want, basically. So if you've only got the one module and you want to use it for something else, you can just unplug it and then plug it in here when you want to use it as a low voltage a low resistance meter. So it's up to you, but I want to make this a nice low profile job, and I'm going to keep this. I got quite a few of these cheap. I got a box full, so they didn't cost much, so I'm not going to use the headers. I'm going to just put them straight into the I'm going to put it straight into the PCB like so. And basically this PCB is just acting like a motherboard, so if you get what I mean, you just put the module straight in. There's just a few passive components to put in, and like the transistor and the diodes, and the variable pots. And so I'm going to do the same with the LCD. That's going to go straight in there, so it's a nice flat profile. Basically, that's what I'm after. But as I was saying, I was on about this extra thing here. So these are in two separate widths. So basically, what can happen is, if you've got the wider one, because the pins are all the same, and if I can get my eyes in the right direction, we can have the wider one as well. It'll take either one. So the wider one fits like that. It brings the USB close to the edge, but who cares? I've made the board hopefully to take the whole thing. And the same goes with this bottom one here. What we're going to use is, we're going to use the one out of here, one I've already got in here. I'm just going to plug that straight in here. But there are some wider ones of these. They're a bit wider in this direction, and that's why I've left a bit of extra space here underneath. I don't know how wide they are. I'm just hoping that I've left enough room. So let's get started. So what we need to do, what I'm going to do, is I'm going to start with the through hole and also this piece. Now normally I would add this piece, a surface mounted chip, using my hot plate. We can do that, or I'm going to attempt something new. I'm just going to try and put it on with my soldering iron. So let's have a go at that first. I'll just get set up. Right, so I just don't want it to sort of move around. I'm holding it in my sort of like, what they call that, third pair of hands or what have you. I'm just going to use one of these clips that I've modified. It's a hair clip. The reason I've used a hair clip is because the length is just like a long crocodile clip, and we can grab it from a great distance. So that's going to go on there and hold it, and I just need to line it up. So I made it sort of to go to the front there. This is where the silk screen is important. So you can see that the silk screen for this is, can you see the silk screen? I don't know if you can see that, but yeah, see, get a bit of focus there. Yeah, so I'm going to line it up with a silk screen. So having a good silk screen is also very important, which PCBWay do. So let's just line it up with that. And we can see it's the same on both sides. Can you see it's the same on both sides there? Oh, my light's getting in the way, but yeah, just left a little bit of gap there because I've actually put it on further back than I wanted. I've just moved it forward a touch so it's flush with the edge there, basically. Yeah, so let's get that soldered in place. We've got 4 pins across the back, which are going to be the easiest to access first, so I'm going to do them 4 pins, and then there's 2 like strengthening posts here at the front where you can put a bit of solder to give it some strength when you're pulling stuff in and out. So if I grab my soldering iron, if you know about these soldering irons, I've done a video that shows you how to get your logo on there. Yeah, that was quick. So let's start getting it out of the way of the my light, if I can. I think it's because I've got it tilted. Let's just try and tilt that a bit more. Get the light out. What's that? I've got telephoto as well. Let's try that. Bring that up and telephoto. How's that? That looks good, doesn't it? Yeah, so you can see I've got it there. My soldering iron's at 300. since one of these is going to be ground, it's going to have a... No, it isn't, because these aren't ground. So I'll just put a bit of solder. If my hand doesn't shake. Got one. Got a bit too much on there, like, but same there. We'll get rid of that. What I'm going to do is I'm going to tip it the other way. Can you... and try and keep it in shot. Yeah. I just want to warm the PCB up a bit, really. I should really put some hot air on and preheat the board, but I'm just going to use my soldering iron. Once we get some heat in there, things are going to flow a lot better. I just want to get some of that solder off there and onto this next pin. Yep, there we go, get some more off there. Too much on it. Let's see if we can get onto that pin. I hope I'm getting all this on camera, because I'm not looking at my PCB screen. Not my PC, not my LCD screen. I'm not looking at my monitor. I should do. There's too much on this pin here as well. Like, just drag it off. Now there's some heat in there, it'll all flow. And of course, if you watched my view on flux and stuff, as long as you don't get the temperature, once you keep it within range of a temperature, the flux that was in the solder is enough to put them on there. We'll have a close look at them. Well, yeah, I don't need to get my microscope out, because now I've got the telephoto on here. Should be quite easy to see that. So what I want to do, you're not going to see this. Now, let's just take that off. You're not going to see this easy because it's a right awkward position, but get rid of me handy holder thing, and what I'm going to try and do is position it so you can see. Don't know if I can. Just get rid of me soldering iron. Yeah, let's try and get that zoomed in there. But there's like a there, you can see it now. There's like a metal plate in there. Actually, if I can hold it like that, let's get me handy. Let me just set this up. There, you can see that now. You can see that plate in there. So what I want to do is get my soldering iron just in there and get some solder on there as well. I've got a bit of solder on the end. I might just want to add a little bit more, so I've got a bit of fresh flux from the solder. I'll just get that in. I don't know if you can see that, but it should just all flow in there. Let me just change my glasses so I can see if it looks like I've got it, doesn't it, I think. And I just need to do the other side, really. So let me set that up as well. Yeah, right, so I've got it turned around. Let's see if I can get the soldering iron in there. Yeah, I just want to put a little bit more solder on, just a tiny bit, just to get a little bit of extra flux, and then I'll just stick it in there. Once the PCB gets up to temperature, it should all flow. And there we go, it's done it. It's quite a bit of solder there. Put a bit too much on there. But anyway, it's moved all the way across there now. Yeah. In fact, what I'm going to try and do when I do this is I'm going to try no external flux. I did a video about flux, and there should be enough in the actual solder itself to do what we need to do. And let's have a closer look at what I've actually done here now. right, I'm going to try and get as close as I can with this camera, so let's see if it focuses. So I don't know if you can see, but we actually have got solder in there. I was trying to miss the plastic. I don't want to melt the plastic. And on this side you can see that we've got plenty of solder in there. If my hand would stop shaking you'd probably see it. And then these are the 4 pins. I got far too much solder on this one here, but you can see that we've got plenty of solder on there using the flux we had. That's in there. Some of it's a little burnt, but most of it worked alright. So we've got that on there. So now what we can do is, what I'm going to do is, I'm going to pluck everything out of my solderless breadboard and we'll put them on. I think we'll start with these two potentiometers here. These two things here. Oh no, we'll put these diodes in because they'll get in the way otherwise. So put the diodes in. We'll put the transistor in. So we'll pluck them out of the board. Just one moment. Oh, right. Before we do any more soldering, right, I want to talk about the OLEDs. I've got two to choose from. So this is the one that I use to for my projects. It's got on a stand and everything, and I plug it in and we use it. And it's just like a bluish white thing, but these come in many flavours. Now they're all monochrome, and what I say is, when I say monochrome, they have LEDs which are either on or off. The LEDs don't change colour. They're whatever colour you want, but they stay that colour, if you get what I mean. And I've got two examples here. So what I do is, when I'm designing a menu for my projects, I always leave the first 16 bytes, so the first 16 pixel rows as the menu, because when you buy these you can have these with the top 16 rows of pixels a different colour. It's still monochrome, so it's still like an LED is either on or off, but the colour of the LEDs you put on the screen are made in the screen can be different colours. So what they do is, for some screens you can have the top 16 rows of LEDs a different colour, and that's just what I want to show you. So I'm going to plug this in and tell me what you think. So if I plug that in, this screen should start up. There, can you see that the top row is yellow, and it looks a bit shit on the flash screen, and I'm going to alter the flash screen for it as well. So what I'm going to do is I'm going to make another video about creating your own flash screen. But you can see now that what we have is the top menu, well, the top title, shall I say, is all in yellow. We can't change that colour. It's always going to be yellow. The first 16 rows is going to be yellow, and then we've got the rest is like a bluey white colour, and that looks really cool. So what I'm going to do is I'm just going to swap this over. Right, yeah, so I've swapped it over and I've got a different screen now, so I'm just going to plug it in. And there you can see the flash screen looks great. It's all white, and the whole meter is white, you know, so we've got white LEDs throughout the lot. They're not, it's more white than blue. Well, actually, to the human eye, for the camera makes it look a bit blue, but to me this actually all looks perfectly black and white, and it looks really cool. But I do prefer the other one. I want to put the other screen on with the yellow top. So let's just change. Here we go. Back to the other one. Oh, hang about. I didn't unplug it. I have to reboot because you have to actually, when you're using these monitors, you have to actually set them up. You have to initialize them. So just swapping up these won't just let it run again. So we have to boot up again. And this is the one with the yellow top. There we go. So yeah, I might change that. Well, all that we need to do there is to drop my character head further down. So yeah, I prefer this one. I'm going to go for this one, and this is actually a blue, so it's yellow and blue. They're not white digits, so I'm going to go with this one. Right, so let's continue with the build, and we'll choose this one, the one with the red thing. I'll put the other one away. It come in some nice fancy boxes, and these were the cheapest. So they come in a box like that. So yeah, cool. Right, just give me a moment. Yeah, right. So I'm going to stick these two variable pots on first. One of them is, let's say, the pins are okay on it, and the other one, the pins are not so okay on. Don't know if you can see that. I've had to extend them to put them into my into my breadboard. But basically what I'm just going to do is clean this up so it'll go into a PCB. But these are the only two pots I have. One of them is of this value. Can we see that? It's not letting me. Yeah, so this one is 10 ohm and the other one is 100 ohm. I forget which ones goes where. But we can look at our PCB to find out. I've written 100 on front as well. I don't know if you can see it. I can't get it to show up. Right, hang on. Alright, so yep, here comes my first cock up. Right, so looking at these two, let's see if I can get them in focus. Let's get the yeah. So yeah, I thought these were both the same, exactly the same, except for different values. If I put them side by side like this, they look pretty much the same to me, don't they? I don't know if they look the same to you, but it looks like the same package, same thing. But I didn't realise, because I had soldered some long legs on them to get them into my board, and now let's take a look at them, see if we can get some light on that. Yeah, can you see that this side the pins are frigging different? Look, if I line them up. So yeah, I've cocked that up. I've made them both. I've made the holes for this to fit, and this one doesn't fit. So these are the only two I've got of these values. So I'm just going to bend this leg. Well, I should really bend these two legs so they match the position of them two. So I'm just going to do a bit of fiddling and get this one to fit in the hole. So what I'm doing, I won't bother showing you my struggle with that. But yeah, it's this size, it's this pitch. It's basically what we've got is we've got 2/10 of an inch going across, and 1/10 of an inch going up and down, whereas this one has got 2/10 of an inch going across and 2/10 of an inch going up and down. But it's this one that we want. So the reason I made these also is because to get better adjustment, you could use these screw type, which basically have the same footprint. Right? Well, these actually have the pins on the end, but you can get them with the pins underneath here as well. So I thought I was making it universal when I did this, because the actual casing, if you look at that, can you see them lines? the casing are pretty identical, really. So so the footprint is the same as long as you get it with the pins coming out of the bottom. So I'll leave it with that, and I'll just struggle to fit them in here. Yeah, here's what I've done. I don't know if you can see that, but I've sort of like bent them up a bit like that, and now this will fit in there. And this is the 100, so the 100 wants to fit in this top one, so that will go in this one. And it actually it does, because they've got these have actually got feet on. It's actually sat okay. It looks pretty good. And when this one goes in on the this one goes on the other side, they don't actually look too bad, do they? They're going to go all right. So let's just turn them over and stick them down if I can on my bench. There we go. Are they in place? No, I've lost one, haven't I? I think. Alright, I'll tell you what, I'm going to use the clips. Just give me a minute. There we go. I've just got this clip. It's just soldering them both in place, and the pins are sticking through. The ones that ended up shorter are okay, and these are just right. Basically this is a pull from another board, so the pins are just the length they need to be. They've been clipped already. In fact, actually what I'll do is I'll just bring this back and hold it so you can actually see. Let me set it up. There we go. So you better see what I'm doing. Actually, I mean, right, I zoomed out a bit so you could see my board. So what I'll do is I'll just see if I can zoom in a touch. Yeah, go telephoto, see what that does. Right, so that needs to go further back. Right, so now you can see them. So because they're a tripod, basically tripod, I'm going to solder them all. It doesn't matter if I need to just push one down a bit. I can do, because it will always pivot on two to change the depth of another. So I'm going to solder all 6 points at the moment. Let's do that. Solder. Oh, hang about. I forgot something as well I want to mention, because I'm going to do it off screen in future. Let me just move that lot about. Right, I'm not one for all these cleaning shit and stuff, but basically this is my solder. This, right, what I want to just say is my soldering iron's been sat there. It's at 300 degrees. If you saw my other video, at 300 degrees the flux is going to get burnt off, so there's actually no flux on this solder that's on the end of my tip. It's burnt away. 300 degrees. Actually, I've got it at 330. Why have I got it at 330? I've got it at 330 for some reason. I must have pressed the button. Right, so what I want is that one. I want it at 300. So at 300 degrees, the flux is going to get burnt off. There's going to be no flux on the end of that tip whatsoever. We need to add some more. But rather than use an I said I'm not going to use an external flux on this, just to prove a point. So what I do is I have this tub. It gets filled up with all my bits of flux. But you've seen them sponges. You've seen, I don't. A wet sponge is okay. I do think they're okay. I've got a wet sponge somewhere. I don't know where I've put it. Oh yeah, here it is. Here's a wet sponge. You can use a wet sponge. But the easiest thing I find is solder, the excess solder on here, and because there's no flux, all you have to do is just wipe it next to another piece of. I'm going on, yeah. So I just wipe it against another piece of solder, this blob of solder here, there, and that has cleaned all the solder off, and we can add some fresh. So we can just add a bit of fresh there, and the solder I've used in this wire has got flux in it, and what's that's done, it's just reflowed and cleaned all the flux on my tip, and that's the way I do it. I just put a bit of flux tin on there and just give the tip a wipe, and it's all ready to go. It's got solder that's got flux, and it hasn't quite burnt away yet. So let's bring my my piece back now, and now that I've got a tip with some flux that hasn't burnt away, we can now start adding some more to the tip. So just add a bit, and what we need to do is we need to just add a little bit to start, quite a bit to start with, because what I need to do is I want to heat up the PCB again. The PCB wants to all be warm, so you just hang about in the same place for a little bit, and the PCB will get warmed up. I could use a bigger tip, but like I say, we all have preferences and we all do it our own way. In fact, this PCB needs warming up quite a bit. Actually, I think this time I'm on a yeah, definitely on a ground pin here. Yeah. What I'll do is I'll come back to it. I'll just get the PCB warmed up. In fact, I've got too much ground plane on this. I might actually change my tip. I want to get a bit more heat in with this. This is a tip I usually use for surface mounted pieces. Yeah, it's definitely too cold. Should flow a lot better than that. Nearly got it warmed up. It's better. Warmed up there. I'll just take this clip out of the way. Yeah, that's definitely been a pain, is that? I'm just going to put a bit of boost into that. There we go. Be the same on this one as well. Yeah, I think for the through holes what I might do is I might change out the tip. We'll put some plenty of heat in there. Like I say, I won't up the temperature. It's just that this it needs a hell of a lot to get right to the tip. So that's fine for me. That's them three things in. Just take a look and see if they're all sat nice. I hope I was all on screen there. So, do they all look sat? I know one's not going to look really well sat because I've got the bent pins underneath it. So let's just see if I can get that sat a little bit better. Ow, it's warm, is this now? Definitely got the circuit board. That's alright. Might just see if I can just crush that pin down. Oh no, I've actually got some solder underneath it, that's why. It'll have to stay like that. It'll have to stay like that. It's a bit of a mess, I know, but oh, well, we'll find out. So I'm going to put that switch in there now, since we've got all this warmed up. That's quite a heavy piece, is that? So instead of using the switch that got me bored, I've got another one. So that one I'll just plug straight in there. If I can get me right glasses and see what I'm doing. So yeah, let's just hold that in place. And we have that held in place there. Does it look alright in that direction? It looks sat right down, doesn't it? So I reckon we can actually solder that where it is. But I'm going to change my tip. Just give me a minute. Yeah, I put this one on since we're doing throw hole stuff now, and since this has a big block of copper at the end, it's going to work fairly well. So let's just see how this goes. A bit too big, but anyways, right, so the easy way out with that is I'll just take this off. No, I'll leave that on. See if I can get it all in shot. Let me just, I don't like is that in focus? It sort of looks in focus. Right, let's just grab the solder off that. There. I mean, this sticks plenty of heat on there. I don't know if I got that on shot, like, but with one of these, it just puts plenty on. Yeah, that's done. So just give me a minute. I'll just drink my tea before it goes cold. Yeah, right, so I'm just going to pluck these components out of the solderless breadboard as I use them. So, you know, there's one thing I forgot to do, and that's add a capacitor. I wonder if it really needs it. I hope there's enough on the actual components. We'll find out anyways. So, if you're wondering where I'm getting the components from, I've got them already here, and I'm just plucking them out of here. So let's continue, and then I can zoom in again. Let's yeah, zoom in again so we can see what I'm actually doing. Let's put the two diodes in. Yeah. So well, actually, yeah, these are two set apart. I think I've got two more somewhere. Let me just check. I just don't want to keep bending these wires to suit, so let me just have a look. Yeah, I can't find them. That much junk on my desk, I don't know what's what. Right, yeah, so I just need to make these a bit narrower. I tend to use a pair of pliers. That way I'm putting all the pressure actually on the lead itself and not the actual component. But anyway, you can use a former to bend them or whatever. But yeah, bend them something like that. And like I say, it's got a black bit, and then we've got a stripe on there, so get them the right way around. And then squeeze them in, like so. They look alright, don't they? Oh, a bit out of focus. Is it? Let's get it over there. Oh, I don't know. Maybe it's just my eyes. We'll turn it over and we'll just solder them in place. So yeah, you can see them. I'm not one for bending the leads over. If you ever want to take them out again, it'll just make it harder to get them out. So yeah, leave them as they are, not falling out. So like I say, this will have got no flux on it at the moment, so I'll just wipe the excess solder off, and then we can add a bit of fresh solder. And what we're actually doing is we're actually adding some new flux, because basically we've burnt all the other flux off. There we go. So I don't want to get them other. Oh, there we go. Actually, the swap hands. So yeah, like I said, plenty of heat in this one, so it'll just make the whole stuff run. Just quick touch and it's done. Right, so I'll just snip them off. I get tangled in my wires, microphone wire. Where's me cutters? Yeah, snip them off. There we go. Snip these short while we're at it. It'll tidy them up as well. It won't make them look as shit as they are. There we go. It's made that a lot cleaner. It looks a lot better now. Snip the tops. So what's next? Oh, the transistor. Yeah, let's stick the transistor in. Does that look? No, they're a bit skew whiff out there. Never mind, I don't give a shit. Yes, I do. I really like them straight. So transistor. Where's that? Right, this is the one I've used in the thing. I bent the wires a bit. Can you? Have I got all in focus? Yeah, it's good. So yeah, the silhouette, the silk screen, it helps us put it in the right orientation. Actually, they want to be a bit. Oh no, that's perfect to them, aren't they? Let's stick that in there then. I really want to get it a bit lower if I can. I'm going to reshape this. You can see how it's shaped there. What I want to do is try and bring them bends further up. So this, cause like I say, I do want a low profile, so I'm just going to change that. Give me a minute. Yeah, there we go. I've just altered it slightly. Try and get the legs a bit further down, so I just bent them so it'll sit in further. Yeah, get that down as far as I can. So there's the transistor in. Let's spin it over. Right shot, yeah. Right, so we'll just put a bit of solder on that. Right, so just clean the dead stuff off the end of my tip, and we'll just put a bit more fresh with flux. Just want to check that's all nice and straight. I want it a bit there we go. Bit too much solder ran through. I guess I'm getting too fluxy and there we go. just get rid of a bit of the solder. There's too much solder through there. What I do is I just sort of hold it sort of so it hangs down, and just put my solder iron underneath to drag it all out. Anyway, there. I don't know if that was on camera. I've just dropped it on the floor. One moment. Right, let's trim the legs off there as well. And yeah, I think I've got it shot. Yeah, that looks alright. What's next then? Oh, there's two resistors in there. Well, let's do R1 and R2. So R1 is our 1 ohm resistor. Where are we? R1, yeah. The R1 is the one that we calibrate, and it needs to be close to these A2 and A3, because we're actually measuring the voltage across that R1. Let me just check it fits. Yeah, let's put our 1 ohm in there. And stick that in them holes. It goes in there. Does it fit nice and snug? Yeah. That's a nice snug fit. Turn it over and do the soldering. I'd find this a lot easier if I didn't have to do it on camera. But you know, that's the whole point of this video. Right. Where are we? Oh yeah. Soldering iron. Right, yeah, so you can see you can see there's burnt shit on there, so let's just clean that up, and we can solder them. Yeah, right, let's just trim them. I'll just check that it's sat nicely. I haven't poked it, let it drop. Yeah, it looks alright on that side, so we'll trim them. There we go, and what is our next one? That's our R2. What is R2? Can't remember what R2 is. Find out what R2 is. We need to look at our circuit board. Where are we? Yeah, we can look at our circuit board. But I mean, what I could have done is I've got another plug-in which gives us a bill of materials. Done that before, so oh, hang on, shit. Right, what I want is just right, it's our 120R. So let me just find that. But I can't remember which one it was. Yep, found it. Actually, it was the only other one there. Actually, I don't think I've got any. Oh yes, I have got some 4.7K on there. They're on the other side of my solderless breadboard. Didn't see them. Anyways, this looks a bit tight there. Oh, let me just reshape that. Can I just get that in shot? I don't know. Yeah, it's in there. Bit loose that, so what I might have to do is just pull it up while I'm soldering it. Have I got that in shot? But bollocks. Oh yes, I have. There it is. It's out of focus though. There we go. So let's just pop a bit of solder in one of them first. Do it with this hand this time. Right. Tweezers. Just pull that up a bit. Make sure it's up. Take a look. That's miles away. Hands full. Right, what we need to do is just put some heat on that. That melt. There we go. Yeah, it's flat now. Let's put some more solder on this one. Yep. Got a right blob on there. It'll get cut off though. Just check it. Yeah, it looks flat enough for me, is that? There we go. Yeah, so actually I need to dig out for these other two. Where are we? Well, actually these four here. Actually I didn't use them to them. I'll just need to dig out these four resistors because I'm going to leave the two that I have in my board because it's in my solder breadboard because I use them all the time. 1 minute. Here we go. Yeah, just checking which is which. So R5 and R6 is a 4.7K and R3 and R4 is 100. And that's what I've done. So I've put them in there. Let's solder them up. Thing is, I think they're going to fall out there. So I'm just going to stick that over top of those and add another one. And I'll stick that over top of those. That should hold them sort of flattish. Let's just put some solder on the middle four, shall we? No, I can't remember whether I paused or what on that. I wonder if I left it going. My memory's just gone. Oh, this has gone cold. Turn it on. Yeah. Alright, so I have to get used to this solder. It's wider than I got. I put far too much on there because I bought this. Oh, I wish I could turn that bloody reminder off on my meter. Hope I got that in shot. Anyways. Right. Done them four. Let's get rid of them. See how well they're sat flat. Oh yeah, they're still sat nice and flat. I've got them in shot, yeah, good, good, good. Still, yeah, let's do the others. I'm going to have to get a smaller one of these, I think, because it's way too big, is this? I might go back to friggin' meter. Yeah, right. Just trim them off. go. That's them. They should look alright. Yep, pretty straightforward. I'm not going to put this header on. I put that there as an option, whether or not I might need it at a later date. I don't need it on this. So that just leaves, what does that leave? It just leaves the modules now. So we'll start with the microcontroller. I'll start with, I won't use the one in, yeah, I might as well use the one in the oh no, I shouldn't have taken that out. No, I'm going to put that back. I'm going to leave the one in my solder spreadboard. I've got another one here. Here's another one, same size. Go stick that one in there and we'll reprogram it. So that goes in there. Let's just hold it in place with this. Yeah, so I've just got a clip on it holding it in place. Let's just start with two corners. Let's just check I've got that in shot there. Yeah, two corners. Right. Yeah, it's a good job I've kept this tip in here. Like I said, these pins are fairly big and solid things. It'll need a bit of heat in there, so let's just put that one on there and put this one on here. That's that done, and let's just check that it's in the right place. So yeah, it's flat down on that side and it's flat down on that side. We've got the USB at that end and we've got the antenna at this end, so that looks good. So let's just let's get it all in shot like so. Doesn't look too bad. Excuse the light on the thing. I want a bit of a slope on there. Let's just make sure it's focused this side. There we go. I'm going to go down this side here. So shouldn't take too long with this big tip. So yeah, putting plenty of heat on there. Like I said, one of the big things. Oh, that must be ground, that. Yeah, took a bit of persuading. Yeah, got a bit too much on there. Let me just get rid of some of that. That was going so well, that. Right, just hold on. Just need to get rid of all that excess of my tip. Too much on my tip. Trying to throw it on the floor now. Sorry, it's not in shot. My eyes are bad. Just need to get a closer shot of that. Right, let's try again. Right, I've got it on a slope like that. Basically, what I want is the solder to actually run in this direction. That way it stays on my soldering iron. Is it focused? In fact, my soldering iron's a bit too frigging hot, that's why. Too much. What I did, I held it there too long and it just basically burnt all the flux and the flux in even the solder at that temperature gets bloody burnt. So start with a clean tip and we'll come down the other side. Am I still in shot? Yeah, I think so. Like I say, as long as you don't burn the flux, it'll flow really well. So, like I say, my soldering iron's really hot, so you've got to do it really quick before it has a chance. Oh, I'm on that ground plane again. Right. Yeah. You need a little bit more heat on the ground plane, but I'll come back to that. Like I say, it soaks a lot of heat away and it doesn't fall so quick. So, let me see if I can just clean that up a touch. It's just getting a bit of heat into that ground plane. Right, there we go, that's all that done. I hope some of that were in shot. Right, so let's stick my my LCD on. I'm going to use the one with the yellow thing, and what I'm going to do actually with the with this yellow one, the one with the yellow thing, is I'm going to do another video where I alter the splash screen. Now the thing is with this, it's I don't know if you can see that, it's sort of dropping down. I want it held up there, so let me just find something to pack it up with. One moment. Yeah, what I found is I found a bit of plastic. It's one of them off the DuPont things, and basically it's the same height as what the thing is, so I'm just going to stick it under one corner there like that, and so that is going to hold it all level. But to keep it all in place, let's just stick one of these clips in place, and like I say, we can reach right across to the middle there. I want it sort of on that bit, so so it's holding it down there, and then just straighten it up. Well, what I'll do is I'll solder one pin, we'll come round this side and just straighten it up a bit so it all looks straight. But oh, I've got that too close to them, haven't I? Let's see if we can. Oh, I'll tell you what, let's move this across to the other side so that I can put the clip here. Then that should hold it all, and actually I can straighten it up a bit as well. Yeah, that doesn't look too bad, does it? Yeah, right, let's just get one of them soldered and see what it looks like. Let's just how's that look? Ah, you can see. Now then, is pin 1 which one is the ground? I don't know, I'll find out. Oh no, that's soldered alright. So yeah, let's have a look and see what that looks like from the other side. What I want it to do is to line up with all these lines. So actually it doesn't look too bad, does it? Let me have a closer look. Actually I'm quite happy with that. I'm going to solder the other 3 pins. Right, we still got it in short. Yeah. Let's have a go. Start with this one at this end. Is that the ground? Took a bit of oh shit, I think I got that through. Yeah, I need to get a bit of that out of there. Right, just gonna let gravity to help me here, so just let gravity just get some of that. You're not going to be able to see this because I can't hold it, so the camera, I can't get gravity, I've got to hold it that way so gravity drops it down, and I can't get camera to see through. But anyway, there it is. Far too much solder. Right, so we've got that on. That there is now level. Yeah, sort of. Right, and let's grab this thing out of here as well now. So this is the other thing. Have I got it in there? That wants to go in there. Oh, and I need that bit of plastic again. Put that bit of plastic under there. Get the clip on it. Oops. No, actually it might be better that way. There, that's holding it in place. So let's just solder one of those pins up, shall we? Should be really quick. Another ink ground. Right, so just check on the board. That looks flat and okay to me. Sorry, we're going to go for it. Yeah, put it where you can see it. How's that? Let's just put one out at the other end and then we can take the clip off. Right, take the clip off. Damn, too much on there. That's just yeah, got to get used to this. It's 1.2 mil. It's way too thick, but I'm not going to grumble at the price, as I've said. Oh, this is ground one, isn't it? Get in there. Get some heat in there. Right. Yeah. So I mean, what I usually do is just let gravity take its course. I sort of hold it like that. Get the excess off my tip. Is there any excess? There is a bit. And then all I do is where I get it in from is I just let the let it all come off onto this soldering iron like this. Get past that ground and it comes off with a big blob. Got a big blob on the soldering iron. Take the big blob off. Oh, we've still got a bridge there, so let's just remove that bridge. There we go. And we're done. That looks pretty much like my picture, doesn't it? Let's compare it, shall we? Yeah. Let's go back onto the wider vision. So go to wide shot. There it is. And let's move that across there a bit. In fact, let's move that right across there a touch, and we'll click on that thing there, turn on the SMD and that. I'm going to virtual modules. There we go. So that is what we designed, that is what we've made. So yeah, we look pretty much like what we planned, haven't we? So the next thing is to program that, so I'll just get that set up. Oh yeah, I forgot to mention, you see all these cuttings I've took off this the components and stuff. What I tend to do, get a magnet. If it all sticks together, it's steel. If it doesn't stick together, it's copper. Keep the copper, get rid of the steel. So bin this lot. Where are we? Yeah, bin all that. Keep the copper. I keep the copper, and it all builds up after a while. Copper's expensive. It's not something you should be throwing away. Anyways, that's that. So I've started up Arduino IDE. What you need to install is the ESP8266 little FS thing. It's just a matter of finding a file and dragging it into a folder. Well, hang about. Let's. Where's the folder? Arduino. Right. So in my Arduino folder, you'll see the. Well, it won't show up like this. I've made it show up like this. But you've got like a system there, and you can put system files in there, and that changes the things it does. And then you got settings, you got cache and stuff. And like I say, I've done a if you've noticed, it's got a blue border, not the green stuff. I like the blue, so I made a blue theme for it. Where's the other thing? Oh, tools. Yeah. So there'll be one called tools as well. These are all predefined. These are unknown folders to the Arduino IDE. It looks for these folders, and if it sees something in the folders, it will actually load the stuff up. So if we go into tools, and we can see that we've got ESP826 little FS. You create that folder. You create another folder called tools, and then you put this ESP8266 little FS jar. It's a Java file. You stick that in that folder, and it will actually, when you boot up Arduino IDE, you'll find that you have this little FS button that you can use. So that's that. Also, right, yes. So also, when you download my files from the GitHub and what have you, let's just go to where are we in Arduino. Where's my stuff? My stuff is at the top here somewhere. There we go. My ESP826 stuff, and where's my low ohms resistance meter? You've got all these files in there. You'll have one called credentials public. Now what you need to do is you need to change the name of credentials public to credentials. I'm not going to open this file. It is there. I hope I don't click on it, because I'll have to change all my passwords and things on my internet. But anyway, in credentials public, let's just open that with Notepad. You'll find that in here you have this so line 42 and line 43, you need to put your local network name in here, so that's the name of your router, server, what have you on your network. And then you need to put your password here that you use to connect to your router and local password, your local network. So you put them in there before we do anything, and you save it. And like I say, you save that public file to just say credentials.h. That's it. So we've got all these files in here, and what we do is we open this file, which is the where are we? Yeah, it is that first one, isn't it? Yeah. Oh yeah, it's this one. So we've got this loaded into so you open this file, and it will automatically open up all the other files here that are on these other tabs. You don't have to worry about these other tabs. Well, you can rename that, and you can edit in the IDE. You don't have to open Notepad. You can actually edit it in here. It's not going to load that because I've asked it to. So in here, so all you do is load it up, and you go to tools, and you go to your boards, If you haven't got the ESP8266 boards in there, where you can choose node MCU version 1 ESP12E module, you click on that and it should load all this stuff in for you. I've left it at actually, let's speed it up. I'm going to speed this up actually. Yeah, let's try it at 160 megahertz. Right, so yeah, so you can have the speed at 80. It's a stable thing. So if you basically, if you've made and written a program that is quite comprehensive and it does a lot of work, and you don't want to let it slip up, you give it a bit of time to do things, and you just run it at 80 megahertz. If you don't care about that shit, and you don't want to save power and batteries, or we're powering this off the USB anyway. You can up the clock and it'll run faster at a faster rate. The file size, just leave it as the default. I haven't bothered changing that. There's plenty of room for all the files with NFS files. Basically, it split the memory in half as this first choice, which is you've got 2 megs of file system and 2 megs for the flash code. Leave everything else as default. Coming down to arrays, flash only. Right, if you're sticking a new ESP8266 module into your system, then the first time you do it, you want to delete all flash, get rid of everything when you first program it, and then if you update it and what have you, turn it back to only sketch. So what I'm going to do is going to do all flash and everything just to start with, and that's going to wipe all the flash clean and start from scratch. So we'll click on that. Your port that you plugged in, I haven't got it plugged in at the moment, so whatever port is allocated to your ESP8266 when you plug it in. Let's go to here and let's just let's see if we get some smoke and sparks by plugging it in. Oh, I'm just going to have another look on back at my soldering first. Just give me a minute. It's always best to check your soldering, what's on the back. And just make sure you put no shorts in there or anything before you plug anything into there. So just give me a minute to do that. Yes, it was a good job I did that. I did find one which was slightly bridged up there. Let's get focus on that. Yeah, and I've cleared it. One of these was sort of bridged. So, and I haven't trimmed all these off yet either, so, but there's one thing I've forgotten to do, and that is to solder the bridge, these solder pads. We need these pads on the back setting to whatever we've got on the front of this. So, yeah, let me just zoom in on that. Let's go with the telephoto. Right, yeah, that looks better. So on here, actually, I'll just get my hand as well. Right, yeah. So on here, let's just get it to zoom in. That right, focus. I mean, so on here we've got VCC, ground, SCL, and SDA. Now when you buy these OLED screens, they can be in different orders. Ground could be here, VCC could be there, SDA could be there, and SCL could be here. They don't stick to one rule. It's whatever makes an easy life for them when they're doing the PCB. So what we have to do is we have to connect the right pin to VCC, ground, SCL and SDA. I'm going to cough, give me a... there we go, I'm sorry about that. My voice might sound different now. Right, so if we look on the back now, and so we can see I've got where are we? So I've got pins 1, 2, 3 and 4. So if we look to see what pin 1 is, there, so I need to remember when we turn it over that's going to be on the left hand side, right? So that's going to be on the left. So pin 1 is this one here, which is VCC. So if we go back, we know that one is VCC. So what we need to do is make pin 1 here. So we need to VCC, which is the 3.3 volts. It's the power pin. So we need to solder across this joint here. So let's see if I can do that while we're here. So I want the joint on the right. So pin 1 wants to be connecting to 3.3 volts. So let's see. Hang on. I just need a bit of solder for it. Oh, let's see if I can zoom down on that. There. Let's see. Glasses. So there. So. There we go. That's got that. A bit of crap on my soldering iron. Right, so there. Can you see that I've soldered the centre bit with the bit on the right? So this is pin 1 and that's soldered to VCC. Can you see that the other piece is not joined? You've got to make sure that we don't join the other side. Now pin 2 though, so because this is pin 2 and that's pin 2, pin 2 there will be ground. So that's the ground is next one. So if we look at pin 2, which is ground, so we want this one on this side this time. We want to bridge across here these two pads so that we connect pin 2 to ground. So let's just do that. I'll put it down again. Focus. There we go. So what we're doing is now we're bridging that to ground, and I've just got my mic cable all tangled up with my soldering iron. Yeah, there we go. So we're going on the opposite side this time. So we're going over here. Yeah, this is definitely ground plane, so we just need to put a bit of heat in there, and that should be bridged, hopefully. Move my soldering iron. See if we can zoom into that. There we go. Now you can see that that pin 2 is now soldered to ground, and we've left this clear. Now we need to do for the other side for the clock and the data. So if we look, let's do pin 4, which is going to be the outer pin, which is going to be the data pin. So the data pin is pin. Is that soldered there? This is how I bought it. They don't look soldered, does it? It looks like there's a. I'm surprised that actually worked. That have you seen state of that? Oh, I'm going to run some solder over the top of them anyways. Right, okay. Where was we? Right, so so data is on the outside. So if we look at this on this again, so the data one is on pin 4, so we want to solder this bottom one here, pin 4 to data, and what we want is the clock to pin 3, so we want to solder this one and this one. So data 4, let me just there we go, data 4, sorry, I just don't want to forget. Data 4, data 4, right, so that is that side, and this one, data 4, yeah. That's what happens. You see, it's sticking to the silk screen. Well, the solder mask. because it's too friggin' out. I'm going to scrape that off there. Oh, I haven't soldered that. Let's try again. Get rid of all the crap on under my tip. Shit. Right, it's over in that middle bit. There we go. Got it there. I think I've got it this time. We'll check under the camera. Right, yeah, so oh, it's this side. So clock is there, and we haven't soldered across that bridge, and we haven't soldered across that bridge. We've done that bridge. Good. Let me just scrape that crap off. Yeah, this is where I had nails. Yeah, give it a wash with alcohol in a minute. Right, yeah, so yeah, that's what I forgot to do. So now we've got the power. We should have power to this. So let's continue with the IDE. Yeah, so we've got them settings. We need to plug it in now. Yes, so yeah, just remember before you plug it in, just check all the contacts and make sure you've got nothing bridged or anything. Otherwise, we could end up seeing a bit of smoke. Yeah, there's our thing. There's my USB. Let's try plugging it in and see what happens. Well, it went ping. Right, so it went ping and it won't do anything because this isn't programmed. So what we need to do is we go to tools, and you can see that I'm in port COM11. That's what this one's plugged into. So once you've got that your correct COM port plugged in, you can check by if you go down to COM port, see what COM ports you have, unplug it, see what disappears, and then plug it back in and see what comes back. That will be your COM port that you choose. Okay, so once you've done that, you just click this. Let's get rid of it. Once you do that, you just click the upload button. We just wait while it compiles. Well, I wonder if does the light flash while it's doing it? Oh, it's not uploading yet, it's still compiling. So when it goes, changes colour, it starts uploading. Sorry about that. Right, now it's uploading. So once you get to the yellow bit there, or whatever colour it changes to for you, like I say, I've edited the style of this. When it says 100, it doesn't mean it's finished. When it's doing 100, what it does, it means it's actually doing the 100% of that. Now it's finished. When it says hard resetting, it's finished. It's still not going to do anything because we haven't uploaded the files. Well, actually it does that, but it won't go any further. Oh yes, it will. Yes. No, the other bit is my web pages. Sorry. Right, so we know it's working all right. So there we go. That all went well, thank God for that. But to do the website, we can't log on to this because there's no well, we have got a server but we've got no web page. To upload the web page, let me just bring that back for us. The web page is in this data folder. So inside here there's 4 files. This is just the favourite icon. The icon, you know when you open a web page and you've got tabs, and in the top left corner of your tab you've got like a little icon. That's what this is. You can edit that. There's plenty of editors on the internet for changing that if you want to put something that resembles what you want. This is the index page. This is the actual web page that we actually look at. This is a script that does all the calculations and everything. And this is just styles. This makes it, give it that nice colour. You might want to mess around with this, change the colours to make it look whatever colour you want. It's totally up to you. Anyway, to upload all these files, it has to be in our main project folder, the same name folder as the ohms meter resistance. That has the folder it's in has to be the same name, and it has to be in. They have to be in the data folder, because when we click on here, we go to tools and we go to little fs data upload. What it does, it looks to see what's in this data folder, and it creates a file system that has these files in, and so they're now getting uploaded. You wait till it says resetting pin, and then that is done. Once it's done that, it's uploaded it. Now what I'm going to do before I forget is I'm going to change this back to sketch only, because I don't, if I left it on let's have a look at the choices. Erase, right, yeah. So if I left it on all flash, what it would do when I uploaded a sketch, it would erase all these files that we've just uploaded. So now what we do is we check it's only on sketch only, and that way these files will remain in flash when you update a sketch, and these files will remain there basically. So yeah, that's that. Okay. Yeah, so that's that working. So what we can do is check our web page and see if it works. So let me just start a new web page. Oh right, no, before you can get the web page, what you first need to do is you need to find the IP address. Now I'll tell you what I'm going to do. Let me just bring that up. Let's just go to the home page. Right, let me just bring up Instructables. Oh, excuse me, I've got a cough again. Oh dear, I don't know why I'm coughing. Right, so yeah, on the Instructables is the full Instructable for doing this project. And if we look down in Instructables, this is just to remind me, I've written it all down and I just don't want to forget what I've told you. So somewhere down here, alright, so this is what we've done. We've programmed it, yep. We've done all the, uploaded the firmware, uploaded the web interface, that does all that, libraries, credits, blah blah blah, blah blah blah, blah blah blah. Wi-Fi settings, right, yeah, I've told you about that, blah blah blah. There's some Wi-Fi modes, so you can have it in several modes, but we're doing it on, we're attaching it to your local network by giving it your local network name, so we'll just stick with that. Either case, you still need to know what IP has been allocated. Now, the reason I'm coming down here is because it's not really that simple. Right, where are we? Web interface, it must be down here somewhere. Right, so I've done all the things there. I must have done a picture, I'm sure I did. Oh right, is this it? Oh right, yeah, so finding the ESP8266's IP address. This will be allocated to you by your router. That your network at home will allocate it an IP address. this device does not choose an IP address because it's connecting to your local network. It gets allocated an IP address, because if we was to give this an IP address to use, and it connects to your network might have already used that IP address, so you can't have two the same. It's not allowed. So you need something that controls who has what IP address, and so as soon as this connects to your local network, it will be allocated an IP address from your router. And this goes into detail of how IP addresses are allocated. And so we actually need to find out what IP address has been allocated to the device. It's always going to start with 192.168, because those two numbers are for external use, not your internal home use. Not your actual home network doesn't use these two addresses, it uses only these two numbers, and that's what gets allocated. So to do that, what we need to do is we need to we need to connect, because we're going to do some calibration. That'll come next. Why haven't I done a picture? I haven't done a picture of the what I'm going to show you now. Right, so we've got our IDE, and so what we need to do is we need to go to Tools, and we need to go to Serial Monitor and open our Serial Monitor. And this Serial Monitor, normally it would reboot this device, but it hasn't. So let's try rebooting by pressing reset here. I have to hold it down for quite a while for it to reset, so it just goes through a sequence just to make sure that it does the server. And there we can see that once I've released the button, it's now starting, connecting to Wi-Fi. And you can see there that it's been given the allocated this address 192.168.0.176. Now when you're router or your home network or whatever has allocated that address, it tends to remember it unless it needs it again some time later in date or whatever, but it will tend to remember your device's IP address that it's allocated to you. So more often than not, you only need to do this once, but if you haven't done it for ages, or you've rebooted your network server, your router, your modem or whatever connects to the outside world, it may lose its memory and forget what IP address is it's allocated to anything, and it will allocate it a different IP address. But as long as your router hasn't been unplugged or turned off or anything, and what have you, it will, what it allocates, it remembers what it's allocated to what, because it recognises devices by the MAC address, not the IP address. It's the MAC address of the device that it uses to recognise things, basically, and the IP address is just for us humans to use. So once we know that address, so if we copy that and then we go to I'll bring this web page back again. So if we go to a new web page and we type in there, oh shit, I've got the wrong macros. Just hold on, copy that again. And the wrong macros on my keyboard. Right, and we paste it into the web browser, press enter. We should now connect, and we now see what is actually on this, and it's reading sort of like 0.66. There's nothing connected. That is just, it should be pretty much zero, and I think sometimes it'll drop to zero, but the thing is with my meter, it doesn't, I can't be asked honestly to make it check to see that there's nothing connected and anything, and actually default to 0. Basically, I'm not gonna. I just can't be asked basically. So it more often than not, my meter it requires it requires that something should always be connected to it. Yeah, so now we've done that and we know we've got the web page and all the code is working properly. What we need to do is upload the code again. Yeah, so why are we uploading the code again? Well, we're going to do it 2 more times. The first time is to calibrate it. I need to know this is a 1 ohm resistor here, and I need to know what value it is. Yeah, we know it's a 1 ohm resistor, but the tolerances are with it maybe 5%, so it could be 5% either side of 1 ohm. What we need to do is first we need to make some leads. Let's make some leads. So I'll just get set up and make some leads. Yeah, that's our next step. Make some leads. Right, the cable for your leads. Well, quite frankly, whatever cable you want to use, it needs to be a decent stuff. It needs to be able to carry the current really well, but we're only using 100 milliamps, so it doesn't take much basically. So I bought some of this. I found this quite good. It said it was silicon. Well, I think it is. What I use is like 24 AWG, American wire gauge, if you want to know what that is. 24 American wire gauge. The thing is with wire gauge is the bigger the number, the thinner it is. The lower the number, the thicker it is. You know, so I don't think a big nut. This 30 AWG will be a lot thinner than what this 24 is, and this 16 or so I'll say 15 will be a lot thicker than what this is. So. Do you want to know how wire gauge is sort of? Yeah, let me draw it on here for you. Let me just see if I can draw it. Right, what you have is O gauge. Do you know, O gauge is an inch. So this is O gauge. Just a bit of trivia for you, just so you know. O gauge, right? So that's a circle. That was supposed to be a circle. Well, actually, we could have used this circle here, but that's supposed to be a circle. That's a better circle. Right. So what do you think 2 gauge is? Well, 2 gauge is 2 circles that can fit into that O gauge, and 3 gauge would be, so let's draw another O gauge. So let's say that's O gauge again. 3 gauge will be the diameter of 3 that fit into the O gauge. That is, and then so what you do is what I've got is 24 AWG, right? So what I would have is O gauge, so there's my 1 inch diameter, and then inside there would be 24 more circles as big as there could be, all the same size, that would fit into that O gauge, and that is how you work out gauge. And the fact is that you have American wire gauge. There is an English wire gauge. They're not the same. Anyways, that was just a bit of trivia for you. So yeah, I use this I use this if I can find the opening. I use this. I quite like it, so I'm going to use a red, black, yellow and blue. Now the length of your wires is whatever you want the length of your meter to be, so I'm just going to cut 4 lengths. Yeah, so here's my 4 cables, wires, whatever. I've decided to make them 12 inches long, 1 foot, 300 millimeters, whatever. Oh, you make them whatever length you want, really. So what we're going to do is just trim a little bit off one end. Well, I think if I do one, then you can see with the rest. What shall I use? I'll use the red one. I'll do the red one and then I'll just do exactly the same with the others. So what we do is just wind that up and tin it to start with. In crocodile clips, I'll just put a bit of shrink wrap around these, you know, they stop you actually crushing things. So I'll just tin it first. What do I do with solder? There we go. Yeah, so there we go. That's got that tinned. Now, as we're doing the I've got my wires tangled. Just got my mic cable tangled. Right, so these things, I quite like these things because they're a good grip. They've got a good. Is that coming up on the screen? Yeah, a good grip for gripping onto wires. There is the other type which I used before. I used. Where the hell have I put them? I thought I put them over here. That's, here we are. There's this type. You might prefer this type where it comes out with like two little things. They're slightly different. One hooks, one grabs. I tend to use these for microcontrollers. I can grab right onto the little tiny legs. These ones I tend to use for grabbing wires. So I'm going to use these type for this one. So you just pull off the end to start with. Now the wire, well, I haven't put this end on yet, so we can actually feed the wire later if we wanted. But if you had to put this end up first, you'd need to stick your wire through first as well, like so. And the reason I've tinned it first is so that we don't get all the poking it through a wire. You're not going to get all the stuff spreading around. But what you need to watch out for is these. They only go on here one way round. You'd think that this is a nice flat blade. That there is a nice flat blade, and you can put the wire in this way, or you can put the wire in from this side. Well, no, you need to take a look down the middle. And I don't know if you can see. Let's see if I can focus on this. Come on. There. Can you see there's a flat there? That determines which way round this goes. If you can see that there's this shape of it, there's actually a flat down one side, a cut. That has to go on that way round. Can you see that? That has to go where that flat is on that side. I don't know if you can see it there, but there's just like a little bit that sticks out, and that has to actually go on in that direction, so it lines up with that, like so. So just check which direction that flat is on. So basically what you have is your hole is on the opposite side. You see this hole is on the opposite side to what that groove, the groove is. There, the groove. So you want the wire going through this in from this side. So we need to put this in from this side, like that. So you're pointing to that piece. Let me just put that in there, like so. Oh, better focus. In fact, what we can do now with that, let's get a bit of closer look. there. So yeah, you can see the flat there, which is on that flat, and your hole's on this side, so your wire's got to come in from this side, like so. And we just add a bit of solder. I might actually go back to my other, see how this goes. I might go, yeah, I'm going to go, actually, just hold on, I'm going to change the tip. Change the tip. Yeah, we're back to this one now. That other one, I'm just going to end up, it's that big, I'm just going to end up melting all the plastic around the thing. So is that, I hope that's still in focus. Yeah. There we go. Let's just straighten that up a bit. There we go. So now when this cap goes on, let's see, where are we? Alright, yeah. Let me just get rid of that. So now when this cap goes on, we can feed the cable in from this side. Actually, it was easier other way around, right? But anyway, we'll get that through there like that. That comes out of there. And now the hole's on the right side, and the flat is on the correct side as well. And what you'll find inside here, can you see that there's actually two grooves for this metal bit to go in? This metal bit, actually, you can see this got two cuts. Don't solder them cuts up, because what they do is they help this as a make these things springy, so they can actually flex in and out, basically, when you actually push them down them two slots in there. There we go. So now we have a probe lead. I mean, if you just want to just make some of these, you could make some probes like this if you wanted, just probes. But yeah, the thing is, you need to clamp your current on as well, like so. I find it best just to use two of these. Well, you'll see in a minute. Well, we'll do some more testing. So I'm just going to do the other three. Okay, I've done the other three. Now for the other end, we're going to actually fit them into this plug, and I've got the what do we call them? Oh, I have no idea. Well, it's the clips, I suppose. I've got 4 clips. I'm going to cut them off this strip, and basically I don't have a crimping tool. Oh, crimps, that's what we call them. I don't have a crimping tool. And what I did was I made these. I have an old pair of long nose pliers. I heated this end up, bent it round so it went into that direction, and then I ground a piece out of here, and so that actually goes in like that and crimps. I guess this is just a one-off tool. There isn't another tool like it in the world, I would have thought. It's just something I've made up. So I can't really show you, because I need to hold these, use this and these underneath the microscope, and it's just a visual for me. So I'm just going to crimp the ends of these with these crimps, and then we'll stick them into this socket. So I'm afraid I can't show you that, but obviously normally you'd have proper crimps for these things that would crimp the wires in, but I've just made this tool, and I'm not able to do it under the camera, so one moment. Okay, crimping done. Let's see if I can show you on this one. Might have to put my hand underneath there. Let's just get that in focus. There we go. So yeah, when you're crimping these things, you just need to strip the wire just enough for this part to crimp the actual wire, and this part you want it to actually crimp the sheath around the wire, so that it's got a bit of strength to the cable when you put it in. This will tend to, if it's crimped with this, it'll tend to stop it from snapping at this point when you bend it back and forth like this. It gives it a bit more support for the cable when it's in the plug. So these crimps have like a little spar here, a little tang. So you have to watch which way you put them in. You need to put them in the right way. The tang side goes to this side, and it actually clips behind these little tabs. So but we need to put them in an order. Now what I did was, with my what was it, my solder breadboard, I had certain colours for certain things. So let me just look that up. I'm actually editing from here instead of from here, but you will edit from here. Basically, this bool is calibrated mode. We want to change it to true. We want to put it into calibration mode. So what I'll do is I'll just change this to true, like so, and I'll save that. And then you can see here it's edited it here. And so what we're going to do is, I'll just move this out at way touch. You can see this here. What we're going to do, in fact I want you to see that a bit better. So what we're going to do is I'm going to upload the software now, but in calibration mode. So we'll just go upload, and remember that I've actually changed this where are we, to sketch only, so that when it does do the update, it's only going to alter the sketch and not all the other data we've already uploaded to the file system. So we'll let it do its work. What we're also going to need is a calculator, so I'll just bring up the calculator while it's doing that. A standard calculator, and we all know Ohm's law, which is V equals Ri. So to get the resistance, we need to divide the voltage by the current. So we're measuring a current which is 10.2 milliamps, 10.02 milliamps. So once it's done its updating, what we're going to see on this screen is actually a voltage, and the voltage is going to be the voltage across this shunt resistor, our R1, which is measured by the ADS 1115, which is a 16-bit analog to digital converter. So basically it's getting a value to 16 a bit value, so it's very accurate. So we measure once it's in calibration mode. Where's my, is it there yet? Oh, it's resetting pin. Right, so what I need to do is just reset this, because it's not resetting. Let's see if that resets. Move that out of the way, that out of the way. Yeah, well, maybe I need to hold it in a bit longer. What the? Oh, hang on, I'm pressing the wrong button. I'm pressing. I was pressing. Sorry, I was pressing the one on my solder spreadboard, not this one. Dear. Right, let me just press this button and hold it a bit. Right, hopefully that'll reboot. Yeah, I pressed the wrong thing. See if that reboots. I might have to unplug it and plug it back in again. Right, let's try that then instead. There we go. Right, so I don't know if you can see that. Right, so what we need to know that, right, I'll just rearrange things. Let's get this zoomed in. Right, so we can see R1 equals 0.00098. Let's call that 5. Yeah, let's go as close as that. Right, so what we need to do is put that value. Where's that? What did I say? Yeah, it's resistance is the voltage divided by current. So what we've got is 0.0098. It's flicking between 7 and 1. So let's call that 4. Yeah, that's close enough. Right, and then what we need to know is the current going through it, which is on my meter, and the current going through it is 10.0332. So shall we say 25? Yeah. So this is milliamps. So what we have is so we divide that by where's divide? Divide that by 0.01002. Yeah, that'll do. So we're dividing it by that. That's what we see up there. This is actually in amps. So we've got equals. So our resistance is 0.9820359. Let's just copy that. And what we'll then do, like I say, I use Visual Studio, now that I remember what it's called. And you see this value, it's changed slightly. I think I've used the same resistor, but now that it's in a PCB, the value will have changed. Before it was in a solderless breadboard, but obviously in a solderless breadboard there's going to be resistance between the contacts and everything, so it's actually changed now. So what I need to do is actually change that to that there, put an F at the end because it's a fraction. There we go. Shit, pressed the wrong button. Shit. There we go. Measured value of R1 in ohms for the current shunt. So there we go. That's all. I put it all there actually, but this is AI. This is AI. Just wrote that lot in. It knew what it was. Yeah, so now I've got that in, and I'll save that. What we need to do now is turn this back to false, because I want the meter back now as an actual meter. At the moment we're just reading the voltage. We're reading the current with our external meter, which is O1 meter. So we're measuring the current in milliamps, and we're measuring the voltage to an accuracy of 1, 2, 3, 4, say 5 places. So we've got that now, and we've done the maths to calculate what the actual resistance of this resistor is. It isn't 1 ohm, it's actually 0.0820359281437 of an ohm. Alright, so okay doke. Right, so we've done that, and now what we've done is we've changed this to false, save that. I've saved that. So what we need to do now, I'll move that across. Actually, what I'll do is I'll leave it there. I can send that to back. Can I? Yeah, maybe. What we'll do is we'll bring up my the Arduino IDE, there. And what we'll do now, that's saved, it says false there now, you see, and it's got this new number in there. We'll upload that instead, and then that will be my meter calibrated to God knows how many decimal places, because now we know the actual resistance of this resistor here, and as long as this doesn't get bent, maltreated, cut, bloody bent, or what have you, we don't change, we don't desolder that or whatever, it's going to remain that thing. So there's going to be no change, so we're always going to be measuring that, and that's why I wanted to also to solder these all in place, because we've got a proper soldered connection now. I don't want any resistance by contacts, having them in sockets. But I've used modules because, well, I've shopped around and it's cheaper to buy the modules than it is to buy all these bloody components. If I tried to buy the components separately, I could have made a smaller board, because I'd only need this thing here, this thing here, and this thing here, and the rest I could have miniaturized a bit with surface mount and made the whole thing a lot smaller. But at least you could build this prior to the PCB on a solderless breadboard. Anyways, I'm rambling again. So now we've got an actual measurement of our resistor there. It's 22.1. Yeah, close enough. Let's put a low. Well, I'll tell you what. I'll just clean the place up a bit, and we'll do some testing using the new meter. Give me a minute. Alright, here we are. Let's do some measurements. So if you remember right, so we've got the blue and the blue and the yellow, which is our current, and if you remember the rules of Ohm's law and electronics and stuff, current is the same throughout the circuit. So if we attach our current here at the end and at this end here, the current is flowing all the way through all this wire here and through here, and it's always going to be the same. And I've got it set to low at the moment, so what we're actually doing, let's use my handy, yeah, I've got it set to low at the moment, so the current is going to be about 10 milliamps. So because I'm always measuring that's the current that's actually going through this thing here. If I flick this to high, it'll change the current to 100 milliamps, so I'll just move it across, and now we've got 100. Well, actually we've got 114, so let me just retrim that a bit. I mean, you can, it doesn't matter really. You can have this what you like. You can actually up it. Let me just turn it right. Oh, that's down. Yeah, I think we can get about, what, 290 milliamps through this. If you want that, it'll give you a better value. But I reckon 100 will do, so I'll just turn it down. Yeah, it's about 100. There we go. There, and let me just check the other one again. That should be 10. Where are we? I mean, this is just so you can work things out in your head, really. You don't have to worry about it. It's not really any now that the boards and the motherboard's been made, these are just high and low settings. It's just if you want to use a high or low current, that's all. So if you want to use 10 or 100 milliamps, it doesn't matter. It doesn't matter what they're actually set to, because we're actually, every time I do a the meter does a calculation. It actually reads the value of what it is. So let's just put it on high for the low ohms meter. So that should be on 100 milliamps. That switch must be a bit dicky, is it? Or maybe it's because I don't know why that is. It's changed, hasn't it? No, it doesn't matter, like, but I just don't. It's just I just touched it. Yeah, just banged on the bloody thing. Anyways, right. So forget that. So it doesn't really matter. And what we have is we have the black and we have the red. Now, the black and the red is actually the bit that's actually measuring the device under test, and so it's the black and the red that must be as close to the device under test as possible. So if we put the negative as close as we can to the actual device, so they need to be, that needs to be inside the current. If it's outside, if you stick it on the outside, hang on, let me just stick this other lead on. So this needs to be on the inside of the current leads. So the volt leads need to be on the inside of the current leads. If you have them on the outside, then there's no current flowing on the outside. I mean, it will measure a voltage, but in theory, you really want it on the inside to get an accurate reading. I don't know how current flows over there, because it should be coming down that wire, coming in. It should be coming down this wire, hit it here, and then go through the resistors all the way through. I've just lost my thing because I clicked on it. There we go. And go all the way through. So if I connect something on the outside, right, maybe somebody can explain this to me. If I connect my voltmeter on the outside and the current is going through here, how come it's getting the voltage on the outside? It's not travelling anywhere, is it? Is it or is it? If I move we've got the current flowing through. Them two wires are running, and I'm measuring a voltage drop between them two. I guess it must be just extending this to here. Basically, that's what it must be. This wire's connecting here and going through there, but the resistance in this short bit of cable must be so small that we can't pick up the resistance. I'm waffling again, aren't I? Talking about crap. So there we go. But basically what you should do, if this was a bit of resistive wire, then you should make sure you're connected on the inside to what you're actually measuring. Yeah, so it's the voltage we're measuring to calculate our actual ohmage, and so we can see that we've got 1 ohm there. And if because well, the previous video I've done all that. Why should I bother doing it anyways? What we want to do is to measure something else, don't we? So what I've found is I've got a little coil here. It's a little magnetic coil. I've got a choke. Got a little bit of a choke. So let's just measure them. This is just a choke. It's only got 1 wire on it, I think, or has it got 2? There's a wire. There's a wire. Oh, it must have been a transformer. Maybe it was a transformer. Yeah, maybe it was a transformer. So we can measure. Right. So we've got 1 there. And I'm guessing the other one maybe comes from here. Is there a wire there? I can't bloody see. Come on, focus. It's hard to see, isn't it? Don't think there is. There's definitely a wire there and a wire there. No, there isn't. It's a choke. There we go. There's only a wire there and a wire there. Right, let's have a look and see what resistance that wire is. So remember, you need current. So put your current to the outside if possible, and put your voltage to the inside. Have I got that in? Fucking hell, it's out of focus. Bloody hell. Right. I said the F word. Never mind. It's an adult video, this. Right. Yeah. So your current goes to the outside and your voltage goes to the inside. And so we've got the black one here, which is the volt. Where did I say the other wire was? There, here was it. And the current goes to the outside. So let's put some current through. See what this measures. Right, so that's that measuring. Oh, I've lost the what do you call it? Right, yeah. So we've got like 6 ohms, 6.7 ohms. So that's the resistance of that wire around that bobbin there. So that's the resistance of the wire. So we're down to 6 ohms. So like I say, yeah. Let's measure the other coil. So I've got this other coil here. Let's measure the resistance around that one. What I'm getting to actually is actually measuring a piece of wire. I want to see how accurate this is. So yeah, so we'll get our voltage on the inside. I can't do this without me. Yeah, let's get the current on there as well now. And get the current on there. Right, so that's our current. So, oh right, well that's 15 ohms. That's even. It must be finer wire on that one. Yeah, so we've got 15 ohms on that winding. Oh, right. I wonder if the resistance changes if I take the. This has got this is like a magnetic. This is a solenoid coil. It's got a piece of steel inside it, a little pin. I wonder if it changes when I pull it out. No, it's 15. Still same resistance. Right. So that makes no difference to the resistance, does it? No. Still quite accurate. Right. So yeah. So what I want to actually do is, right, they're all coils. So it shows you the resistance of the coils. We know what resistance the resistors is. Get rid of the resistors. Get rid of that. Right, what have I got here? I've got something here somewhere. Right, got a bit of yellow. Just a short bit of wire there, look, a short bit of wire. And I've got another short bit. Oh, that's not the same length, is it? I thought I had two the same length. Is that the same length? These two are the same. Well, they're pretty close to the same length, right? So, forget the yellow one. So, what we want is we want the current on here. So we should have the current flowing now. Yeah, the current is sort of 99, nearly 100. And then we want the measure the voltage and put them on the inside. So so what we've got there in this piece of, right, I've got two bits of wire. They're both about so long, right? So this wire here, this cable, according to that, is 0.01 of an ohm. This one should be the same. This one should be the same. So let's measure this one. They're slightly different lengths, but let's just see if they're both the same. So take that off there. Put that on there. And that on there. Come in shot. I think I've got that on. Take that one off there. And take that one off there. Can I connect it? Have I got it on there? Oh, right, so that one's 0.012 of a, so there must be, might be longer. Right. So if this was 0.01, right, and this is 0.012, if we put them end to end, there should be twice as much resistance, I think. I don't know, might be talking bullshit. So let's get the current on there and the voltage on there. So these were both put roughly the same resistance, these two wires. Now if I connect that to that, Yeah, yeah, we've sort of doubled up, plus the 2, yeah. So, yeah, that's right. That. Now then, if we go with Ohm's law and we sort of double these up, hang on, let me just bring up, this is easier to do on a web page. Just give me a minute. Okay, fingers crossed. I've never tried this, but right, I've just gone to the parallel resistance calculator, and I think what we had before, we had something like 0.01 and 0.012. Is that right? Hang on, let's just put them together again. Oh, I'll leave that one on there. It's easy to connect to that one. Right, so this has got a thing on the end of it. Right, these wires are roughly about, yeah, 0.012. Right, so I've written in here 0.012, and the other one was about 0.01, I think, which comes out to 0.0055. So if I let's bring that, put that there, bring that to front. So 0.005, sorry, 0.005. So we need to put these in parallel. So I need to connect both these. Right. Right, that's linked to them two. So I've got them 2 wires there. Look, these. Can you see that? I'll put it all in shot. Right. See if I link the other end to this again, and see what resistance we get. Right. So now I've got them both in parallel. Swap my glasses. And what we got? 0.0005, 56. Well, hell. So how accurate is that? I mean, we measured the 2 bits of wire singly. We got the measurements. We put the 2 bits of wire in parallel now, which is them 2 bits of wire there, and we get the result of 0.0055, and I get a result of 4955 or whatever. You know, it's bouncing around a bit, but well, I'm going to end it there with that revelation, shall I say? Yeah, that's a revelation. Well, that's how accurate it is, guys. So I hope you enjoyed this video. How long have I made this video last? God, 2 3/4 hours. Right, okay. I hope you enjoyed it. I hope you, well, find this useful, and I hope you actually like to build it, really. I don't know. But anyways, on that bombshell, shall we say. And thanks for PCBWay for actually making this PCB. Well, it's where I get them all made. I've had no problems to move, really. So, yeah, I'm rambling. Catch you with the next one, guys.